Okay, let's give you guys some more practice. So here, find this purple area. So find this purple area here. Well, when you look at this, you can visualize this as being one block times another block here. When x equals negative pi, if you put negative pi into this x here, then this whole block here will be 0 because sine of negative pi is 0. Okay, so this block here will be 0, and then when you times 2, it will be 0, and then when you times this block here, it will be 0. The point is that this line here crosses this line here, it crosses at negative pi. Okay, so anyway, find this purple area here, and when another word of caution, when you integrate this from negative pi to 0, it will give you a negative area. Okay, so just integrate it as normal. Just integrate it as normal, and then right at the end, stick a negative in front of it, and then it will give you a positive area. Okay, do whichever way you want. There are other ways of doing it, but press pause and have a go. Okay, so to do this, let's just integrate it as normal. So integrate it as normal. So it will be us doing this whole thing here, and then dx here. We're going to integrate it as normal. Don't forget, if we integrate it as normal, it will give us a negative area here. So right at the end, we're going to change the we're just going to take the modulus of this. Okay, so let's just integrate it as normal. So that's us doing this. But then right at the end, if you integrate this as normal, it will give you a negative area. So right at the end, we're just going to times both sides by -1, and then that will give us area equal. Well, let's just integrate this. Okay, so don't forget, we are integrating it from minus pi to 0. We are integrating it from minus pi to 0. Okay, so when you come to integrate this, your eyes should zoom into this bit here. So visualize this thing here as this. Visualize it as 1 plus cos of x. Currently, it's to the power of a half. So we are looking for something. We are looking for something that when you differentiate it, it will give you this thing here. So let's make this to be our guess. Okay, so let's make this to be our guess. So this is going to be our guess, cos of x. When you differentiate this, so hang on, and notice that later on, when you differentiate this, it will be 3 over 2, the bubble here, and then this thing here gets minus by 1, so this will be a half. You see, you notice that this bit here matches up with what we've got currently. It matches up with what we've got currently, and then we've got to times it with the derivative of the bubble. So the derivative of the bubble is minus sine of x, minus sine of x. You see this minus sign here will match up with this sign here. So the point is that when you if you want to integrate this, visualize this as being one bubble here. So let's start again. So your eyes is just zoom into this bit here. Okay, so visualize it as this. Hang on. Visualize it as this. So 1 plus cos. So currently it's this to the power of a half. But we are looking for something that when you differentiate it, it will give us this. So well, looking at this bit, it will be 3 over 2, 1 plus, and we've done this several times. So if you don't understand this, then track back one of the early videos. So this is going to be our initial guess. Differentiate this. Differentiate it. It will give us this. It will give us this 3 over 2. The bubble itself, 1 plus cos of x, and then we've got to times it with the derivative of the bubble itself, which will be minus sine of x. Okay, But don't forget we've got this 2 here. So let's negate this thing, negate it by changing our initial guess. So we're going to change our initial guess to be well, let's negate this. So it'll be our initial guess should be 2 over 3. Then by making this to be our initial guess, we will immediately get rid of this. Okay, so when you differentiate this, it will give you this. Okay, but now we want the 2, so we've got to times this by 2. So times it by 2. So this gets multiplied to the top, giving you a 4. Okay, so hang on. So giving you a 4. Giving you a 4. Well, when you now differentiate this, it will give you a 2 in front. So notice that this matches up with this, and this matches up with this, but then we still got a negative in here. So let's make the adjustment to our initial guess. Let's make this adjustment here. Okay, and then now when you differentiate it, we can now get rid of this minus here. Okay, so well, when you integrate this, it should be this. Okay, so if you differentiate this now, it will give you this thing here. It will give you this thing here. Okay, so integrating this thing here would give us this. So that will then take us to this. Okay, minus 4, the blah blah. It's what we've got here. Okay, what we've got here is this thing here. Is this thing here. Okay, and then don't forget we're doing it from minus pi to 0. So so when you put this into here, cos of 0 is 1, making this to be a 2. So that's this 2 here, and then this is this bit here, blah blah blah. And when you put minus pi into here, then the whole thing here will be 0. Okay, so now visualize this thing here as this. So this thing here becomes this thing here becomes an 8. So this is square root of 8. So that will then take you to square root of 8. And then it gets multiplied to the top, and then blah blah. It will give us this. Don't forget when we integrate it, it gave us a negative area. So now times both sides by minus 1. So basically just get rid of this, and then the area equals this. Okay.